Hello everyone, my name is Kuzga Agnes. This video I'm going to summarize my homework assignment 1 for the statistical machine learning course. The assignment involves the exploring datasets, applying theoretical and computation techniques, and comparing statistical model. I'll be focusing on the plots I have used in choosing the model, and also the cross validation and the model evaluation to solve the regression and classification. Without any delay, let's go into further details. So here I start by uploading the data which was given in the task, and also I use the scatter plot to see the relationship between my data set relationship between the data set the variable of the data set I have, where I have seen that the scatter plot suggests an linear relationship between x and y, as it appears to have a sinusoidal patterns where y fluctuates up and down as x increases. From this pattern, I can see that a linear model is unlikely to capture the relationship effectively. And also I can see that there is a presence of noise in datasets because the data points they seem to be fairly distributed along the curve with some random variation around the apparent trend. So I continue to perform some mathematical computation of the empirical risk of the loss function, and then after I use cross validation error and empirical risk and model complexity to illustrate how cross validation error and empirical risk with the model complexity p, where in the graph I have where in the graph I have seen that the p initially I have seen that cross validation error initially decreased as p increased, as you can see here on the graph, which show that better performance, however, after an optimal p where bias and variance are balanced. This cross validation error lies is due to overfitting, where empirical risk here continues to decrease with an increase as p in p, which indicate better training data fits but purely generating two new data. By continuing on the test error from the stochastic code validation, I have seen that by continuing on comparison of the model, I've seen that the simplest model underfit data capturing linear trend but missing nonlinear partners, which is that in high bias and low variance. Conversely, the overall complex model overfit the capturing data in noise and small fluctuation, leading to bias but high variance, which hinders generalization. The optimal model achieves a balanced fitting overall trend without overfitting and underfitting effectively. I continued by comparing the test error across model complexity, where I have seen that the simple model has the highest test error, showing consistency underfitting and variability across splits. The optimal model demonstrates the lowest median test error with a minimal spread, indicating the excellent generalization and being the best of the three. The complex model has slightly higher median test error, performed on the unseen data, a wider spread, notable outliers. I I continued by performing by check by comparing my model by using ANOVA test to test my error, and also I have used the test error from stochastic holdout validation, and I have seen that the confidence and prediction bands for x, the regression line in this plot represent the fitted values from the optimal model. The green ribbon indicate the 95% confidence interval for the regression line, with which is narrow near the center of the range of the x values and wider toward the edge, and the orange ribbon shows the 95 prediction interval for the new observation data, which is wider than the confidence interval as it accounts for uncertainty to individual predictions and include the variability. By continue by performing mathematical expression for the confidence and prediction band of single observation, and also I have used the bar plot of distribution of the response variable, where On the part 2 I have on the part 2 I have used the built-in error data, where I have seen that the non non-spam category make up about 60.6% of the dataset, which which spam account for approximately 39.4%. This was indicating the slightly imbalanced dataset. I continue by looking the shape of the dataset and also the types, where I compared the four model I have in this data, and I have seen that the row curve shows that the QDA and LDA models have the similar performance, with the curves almost overlapping and staying close to the top left corner, which indicate good class discrimination, where naive Bayes performs slightly worse as its curve is further from the top left corner, particularly at row false positive, when the class confidence structure are similar. In this graph, you can see that AD and QD tend to perform similar, where naive bias assuming further independence. But also I have used the analysis of the box plot for error distribution, where I have seen that the box plot of the error distribution shows the ADA has the lowest medium error and the highest in the quantile range, which indicate consistent performance. A naive bias in comparison has higher medium error and slightly wider spread, which reflecting more variability and access different data spreads. QDA exhibit the highest decision boundaries, has low variance. On the other hand, QDA, which is more complex, has higher and is more susceptible to overfitting, leading to a wider overall distribution. Thanks for your attention.